In this video, we are going to see magnitude and direction of the torque experienced by an electric dipole in the uniform electric field. Let us consider equally spaced uniform electric field. When a dipole is placed in this uniform electric field, a couple is produced. This couple will give a torque. This torque will give a force on this dipole so that dipole will move ups and downs. Now we see how to derive the torque formula for this dipole. For this we consider positive charges plus Q and negative charges minus Q. O is the midpoint of this dipole. Here the dipole moment vector direction is negative to positive. The dipole distance is 2a, so that OA is equal to OB is equal to A. Now we see the force due to a positive charge. We know that electric field is nothing but force per charge. So bring this Q to the left hand side, we get force value. So force equal to electric field into Q. For this positive charge, the force is plus Q into E, and for this negative charge, the force is minus Q into E. So that net force equal to 0, because the magnitudes of force are same, but the directions are opposite. So that net force is 0. So in this case, couple is produced. So the torque is produced. Torque can be found out by force into perpendicular distance between the two charges. So that we draw the perpendicular distance from positive and negative charges. The intersecting point is C. This angle is theta. We have to find out this BC value, that is distance, perpendicular distance BC value, so that we use trigonometric ratio, that is sin theta is equal to BC by hypotenuse, that is opposite side by hypotenuse. Opposite side is BC, hypotenuse value is 2a. So bringing this 2a to the left hand side, we get BC value, that is 2a sin theta, that is equal to perpendicular distance. Substituting this perpendicular distance between the two charges and force value, we get this one. Rearranging this right hand side value, we get 2aq e sin theta. Here 2aq is dipole moment value. So tau is equal to, that is torque is equal to dipole moment into electric field into psi theta. Due to this torque, dipole moves ups and down. Torque vector form is P vector cross E vector, where P vector is the dipole moment vector and E vector is the electric field vector. Now we see the magnitude of torque when theta is equal to 0. That is, when dipole moment vector is parallel with the electric field vector, theta becomes 0. So sin theta is equal to sin 0. Sin 0 value is 0. So torque becomes minimum value. When theta is equal to 90 degree, that is when dipole moment vector is perpendicular with the electric field vector, torque becomes maximum. That is sin theta becomes sin 90. Sin 90 value is 1. So torque is equal to maximum value, that is dipole moment into electric field value. Next we see the direction of the torque according to right hand rule. Keeping the right hand towards the direction of the dipole moment vector and facing the palm towards the electric field vector and curling the finger, and thumb shows the direction of the torque, that is into the plane of the paper.